So this is going to be the lesson plan for today. First, we're going to be learning how to graph polynomials and then learning how to graph rational functions.
To graph a polynomial, the first step is to find the zeros of the equation. To do this, you need to first factor the equation to the simplest form, then solve for x to find the zeros, which you can then plot on the graph. The next step to graphing a polynomial is to find the multiplicity of the zeros. A zero has a multiplicity which refers to the number of times that its associated factor appears in the polynomial. Basically, the multiplicity is the degree of the x. Odd multiplicities will cross the y-axis when graphing, and even multiplicities will bounce on the y-axis. Okay, step 3 is to find the shape of the graph. You can do this by looking at the leading coefficient of the polynomial. If it's an even degree polynomial, both ends of the graph will be facing the same way. If it's a negative or odd degree polynomial, they will be facing in opposite directions. If the odd degree polynomial has a positive leading coefficient, the left end will be facing downwards and the right end will be facing upwards, and the opposite is true with a negative leading coefficient. In the case of an even degree polynomial with a positive leading coefficient, both ends will be facing up, and with a negative, both ends will be facing down. Here we have another example of a polynomial. The first step is to factor. The equation is x squared plus 4x plus 3, which we can factor into x plus 3 times x plus 1. And from that we can get the x equals to negative 3 and negative 1, which are the zeros of this equation, which we can then plot on the graph over here. The next step is to find the multiplicity of the zeros. Since both of the zeros occur only one time, they both have a multiplicity of 1. The next step is to find the nature of the leading coefficient and the end behavior. In the case of this equation, the leading coefficient is positive 1, so the end behavior will be both ends going upwards in the same direction, because it is both positive and a even degree. The final step is to plug in the points and graph the equation. In our case, we plugged in the left side of the table for the x value and got the right side of the table as the y value. And we plugged in those points into the graph and ended up with a parabola.
Graphing rational functions. In example 1, we have f of x is equal to 2x plus 5 over x subtracted by 1. In step 1, we need to find the horizontal and the vertical asymptotes. In order to find the vertical asymptotes, we need to set the denominator equal to 0. In order to find the horizontal asymptote, we need to divide the two leading coefficients. And so our vertical asymptote is equal to x is equal to 1, and our horizontal asymptote is equal to 2.
Alright, in step 2, we have to find any x and y intercepts. To find the x-intercept, we need to set y equals 0. F of x equals 2x plus 5 over x minus 1 becomes 0 equals 2x plus 5 over x minus 1. We need to multiply both sides by x minus 1, subtract 5 to both sides, and then divide both sides by 2. Then we get the x-intercept at negative 5 over 2 and 0. To find the y-intercept, we need to set x equals 0. this turns into y equals 2 times 0 plus 5 all over 0 minus 1. Then we get y equals 5 over negative 1. That means y equals negative 5. So there's going to be a y-intercept at 0 and negative 5. And then for step 3, we're going to plug in random values to plot points and then graph. So we're going to use x equals negative 2, negative 1, 0, 1, 2, and 3. Plug all those points in, and then we graph. Make sure you dot the asymptotes to make sure the graph doesn't go past the asymptotes. Okay, and now we're going to do example 2 where we're going to graph g of x equals x plus 2 over x squared plus 1. First step, we're going to find the horizontal and vertical asymptotes. We're going to start with the vertical asymptotes by setting the denominator equal to 0. G of x equals x plus 2 over x squared plus 1. We're going to set x squared plus 1 equals 0. Then we're going to subtract 1 to both sides where we're going to get x squared equals negative 1. Now this is actually something that is not possible, so for this graph we're not going to have any vertical asymptotes. The next part of step 1 is to find the horizontal asymptotes by setting the top coefficient divided by the bottom leading coefficient. So in g of x, we're going to divide 1 by 1, so we're going to have a horizontal asymptote at y equals 1. For step 2, we're going to find the x and y intercepts. We're going to set y equal to 0 to find the x-intercept. So we're going to set 0 equals x plus 2 over x squared plus 1. Multiply x squared plus 1 to both sides to get 0 equals x plus 2, where x is going to equal negative 2. That means we're going to have an x-intercept at negative 2 and 0. And then we're going to set x equals 0 to find the y-intercept. So that means we're going to have y equals 0 plus 2 divided by 0 squared plus 1. That leaves us with y equals 2 over 1, which means y equals 2. So we're going to have a y-intercept at 0 and 2. At step 3, we're going to plug in values, plot the points, and then graph. G of x equals x plus 2 over x squared plus 1. We're going to plug in the points negative 3, negative 1, 0, 1, and 2. Where we're going to get the y values negative 1/10, 1/5, 2, 3/2, and 4/9. There you can see the blue dotted line is the asymptote at y equals 2, and we're going to plot the points and then draw the graph.